Now we're going to bump up things a notch, and instead of talking about just an equation in one variable, we're going to talk about an equation in two variables. So we're going to start by going through just a brief overview of what the Cartesian plane is, also known as the xy plane or the coordinate plane. Then we'll see what a linear equation in two variables looks like. We'll talk about how do we find intercepts for graphing, and then specifically talk about horizontal and vertical lines. So first and foremost, we'll refresh if you're unfamiliar with the Cartesian plane, what this rectangular coordinate system looks like. So you're always going to have points that are labeled as x, then y. Usually they're in alphabetical order if you're using other variables, but x and y are most common. So either way you hear this, they all mean the same thing. So ultimately there are two axes, one being a vertical and one being a horizontal. The horizontal axis is called our x-axis, so x goes across. And then the vertical axis is the y-axis, so it is y to the sky. And these continue on forever, even if these arrows aren't there. So you're going to have some scale. It depends on the problem you're working on, but typically one's what we go up by. If you have an equation that has more complicated values, though, then you can use whatever else you need. So if we go to the right, these are considered our positive numbers, and same thing as up. These are both positive directions. If you go to the left, it is negative, and if you go down, it is also negative. The point in the very middle is what we call our origin. It is our starting point. The first coordinate is 0, the second coordinate is 0. And so that is our origin. Every other point just depends on where you need to plot. So say if our x value is 2 and our y value is 3, that point would be right here, 2, 3. So we always go x, then y. If we do -3, +1, that would be the point right here. That should be +1. Right? You can have points that land on the axis as well. It's like this point down here, you don't move in the x direction, you go down 3 in the y direction. So ultimately, this splits our two-dimensional surface into 4 different regions. The very first region is what we call quadrant 1. So you'll often see it as Q1. So that's where they're both positive. In math, we don't move counterclockwise, or we don't move clockwise, we move counterclockwise. So quadrant 2 is going to be to the left, quadrant 3 is down, and quadrant 4 is here on the right. So when we're working with variables or equations that have two variables, there are specific x and y values that satisfy the equation. So specifically, if we're working with a linear equation, what we're going to see is some number times x, some number times y equals some constant. So these a, b, and c are just real numbers, and we want to make sure that these both aren't 0. So we don't have 0x and 0y. That would be really a useless equation or something that isn't even true. So in this case, there are certain x and y values that satisfy this. So if I pick an x value, I'd have to see what is the specific y value that satisfies this equation. This particular form is called our standard form. So in our future sections, we're going to see 2 other types where we have slope-intercept form and point-slope form. So this is just standard because all the variables are on one side and you have a single version of them. So let's start with just some practice. We're going to be given the linear equation and we want to figure out what is the missing coordinate so that it is an ordered pair that satisfies the equation. So we have the line x minus 2y equals 4. And in this very first one, we're told that x is equal to 0, but we have no idea what y is. That's our goal. What is the value of y? So we're just going to plug x equals 0 in the equation and then figure out what does y have to be. So if I plug this in, we need x minus 2y to equal 4. Our x is 0, so we need 0 minus 2y to equal 4. And this is really just a linear equation now. 0 minus 2y is minus 2y, and that needs to equal 4. So to get y by itself, we go ahead and divide both sides by negative 2. And that leaves us with y is equal to 4 over negative 2, which simplifies to negative 2. So the ordered pair that satisfies this linear equation is 0, negative 2. In the second one, the x spot is blank, so we don't know what that is, but we're told that y is equal to 1. So plugging that into our equation, we have x minus 2y has to equal 4. So that's really x minus 2 has to equal 4. And then to get x by itself, we just need to add 2 to both sides. So those cancel each other out, and we're left with x equals 6. So the ordered pair in this case is going to be 6, 1. So you can do this pretty much for any equation. It doesn't just have to be a line. It is kind of the fail-proof method. You pick points and then you can plot them. When we start dealing with more complicated equations, though, picking points isn't as easy and it doesn't help us get a very accurate picture. So we're going to see other methods to actually graph them. But since we have a feel for this, we're going to go ahead and graph the line 3x plus y equals 4. So I can go ahead and plug in values for x and then figure out what my y is. But to make our lives even easier, if we solve this equation for y, we can find the points more easily. So we've got 3x plus y equals 4. If I want to get y by itself, we can go ahead and subtract 3x from both sides. So that will make these two cancel out, and we have y equals. Over here, those are not alike, so I can't actually combine them. What you could do is you can put the 4 first, and then we're subtracting 3x. Or if we like the x in the front spot, that's negative 3x plus 4. Either way works, whatever one you want to use. But this makes my life so much easier because now I can create a little chart. Here's my x values. And then I'm just going to plug them in over here to find what y has to equal. So if you pick like 3 points, that's more than enough to figure out what the line is. We'll pick a negative number, so let's pick negative 1. If we plug this in for x, our y would be 4 minus 3 times negative 1, which ends up being 4 plus 3, giving us a value of 7. So one coordinate, or one ordered pair, is negative 1, 7. If we pick x to be 0, our y value would be 4 minus 3 times 0, which gives us 4 minus 0. So our y value has to be 4. So another ordered pair would be 0, 4. So here's our x, y values. Now I'll pick one more point for good measure. If we pick x to be 1, y will be 4 minus 3 times 1. That is 4 minus 3. So our y value is positive 1. So we also go through the point 1, 1. So like I said, for lines, this is a pretty fail-proof method. It does make things not the nicest to graph though. So our y value has to go up to +7, so I need a pretty large amount in the y direction. Our x, we're only going out 1, but I'll put a second for good measure. On y, I need to make these a little bit smaller, so that's 1, 2, 3, 4, 5, 6, 7. Now, hand drawing, we're never going to be 100% accurate because my scale is definitely not perfect, and that's okay. So our very first point, the x value is -1, the y value is +7, so that point on our line is all the way up here. The next value is x is 0, so I don't move from the origin, but we go through +4. And last but not least, we have x and y both being 1. And then from here, we just have to connect the dots with a straight line. So really, you only need 2 points to go through and draw the line because you're just connecting them. 2 of the most important points for us are going to be the intercepts. So our y-intercept is where we hit the y-axis. The x-intercept is where we hit the x-axis. And the nice thing is, if you're on one of these axes, it means the other value is equal to 0, so you haven't moved off it. So if I want to see where do we hit the x-axis at, our y must equal 0. And then if I want to see where we hit the y-axis, x has to equal 0 here because we don't move off. So these are going to be the 2 nicest points to find, and they're going to be important in every single graph that we go through. So let's definitely get some practice with these. We want to go through and we want to find each of the intercepts if they exist, and then go ahead and graph the resulting line. Let's start with the line 3x plus y equals 6. So we'll start with our x-intercept, which again means we set y equal to 0, so the opposite variable. Plugging that into our equation, we get 3x plus 0 has to equal 6. And so we need to solve 3x equaling 6. And we know how to do that. We go ahead and get rid of the 3 out front by dividing. So those cancel. And then 6 divided by 3 is equal to 2. So when you're talking about intercepts, you want to make sure you're writing it as an ordered pair. The coordinate is 2 and the y coordinate is 0. To find our other intercept, which is the y-intercept, now we set x equal to 0. And this one thankfully is a little nicer because we have 3 times 0 plus y has to equal 6. 3 times 0 though is nothing. So we have 0 plus y equals 6. That just means y equals 6. So our y-intercept is the pair 0, 6. So we have 2 points on our line. We can now graph them. And so for the x, I need to go out 2 at least. So we'll do really 3. And I won't label everything. We'll skip and count by 2s. In the y, we have to go out 6. And then I'll add some scale on the other one for good measure. So our x-intercept is the point 2, 0. The y-intercept is 0, 6. And then a straight line just connects these two. So this is the graph of the line 3x plus y equals 6. If you wanted to find more points, absolutely you could. Now let's try some more different types of problems. So we want to graph the line y equals -1, and we also want to find the intercepts. And this is where things get a little strange. So if I try to find the x-intercept, we need to set y equal to 0. But if I plug y equal to 0 into this equation, we end up with 0 is equal to -1. And that is in no way, shape, or form a true statement. So because of this, I end up with something that's not true. There's no solution. That means there's no x-intercept. So we will not cross the x-axis. However, if we try to do the y-intercept, we need to set x equal to 0. But there's no x in this equation at all. So I really end up with y equals -1. There's no x to replace. So we do actually have a y-intercept of 0, -1. Okay? So this is a very special type of line. It's one of those horizontal and vertical that I mentioned at the very beginning. Your y coordinate is always fixed to be -1. So if you want to get another point on the line, if you let your x be -1, your y has to be -1. If x is 0, your y still has to be -1. If you pick x to be 3, your y still has to be -1. No matter what your x value is, the y coordinate is fixed. So if we tried to plot this, go out 2 in the y direction, 3 in the x, and then we'll go down 2 as well. Our y-intercept is 0, -1. And then the y coordinate is fixed. So if x is 3, y is -1. X is -1, y is -1. No matter what, your y value has to be -1. Okay? So this results in a horizontal line. So if I had y equals 5, that would still be a horizontal line, but it would be up here instead. In the exact opposite case, now if I have x equal to 4, that's going to result in a vertical line. So if we try to do the x-intercept, we still set y equal to 0. There is no y value here, so you still end up with the equation x equals 4. So we do have an x-intercept, which is the ordered pair 4, 0. For the y-intercept, we set x to equal 0, and this is where we end up with a false statement, so something that does not work. So there is no y-intercept. And in this case, I don't have a choice for my x value. I really have the freedom for y. If y is -1, x has to be 4. If y is 0, x has to be 4. If y is 3, x has to be 4. You have no choice for that x coordinate. So ultimately, if we were to plot this, go out 2, 4, 1, 2, 3, 1, 1, 2, 3. Our y-intercept is non-existent. Our x-intercept is at 4. And then if I plot these other points, y could be -1, y could be +3. Your x-coordinate being fixed results in a vertical line. So anytime we have a vertical line, it's going to be in the form where x equals some constant. And a horizontal line is always going to be the case, y equals a constant. So the easiest examples you can think of are the x and y axis themselves. So if I have a vertical line, this is the equation, x equals 0. So it continues up forever. For a horizontal line, that is like our x-axis, that is the equation y equals 0. Or you can pick positive values. Same thing over here. It all depends on what that constant is, what kind or where that horizontal and vertical line lie.